We call Earth the blue planet for a reason, right? So, why are we always hearing about water shortages? It doesn't quite add up. Well, today, we're going to follow the water, from the massive oceans all the way down to a single raindrop, to really get a handle on Earth's incredible balancing act. Right, this is the big question, isn't it? I mean, you look at pictures from space, you see this gorgeous blue marble, and you think, how could we possibly have a water problem? But we do. So what gives? Well, here's the twist. It's not about how much water there is, it's about what kind of water it is and where you can find it. And boom, here's the first major clue. Almost everything you see, a whopping 97%, is salt water. Now, for what we need it for, drinking, growing food, it might as well be on Mars unless we go through some really expensive processing. That means everything we've built, our entire civilization, is running on just that tiny little 3% slice of fresh water. Okay, so for the rest of this conversation, let's just park that 97% to the side. Forget about it. Our entire world hinges on that 3%. So let's crack that number open and see what's inside. And this is where things get, well, kind of crazy. You think, okay, 3%, I can work with that. But get this. Of that small amount, almost all of it is out of reach. Nearly 70% of it is frozen solid in ice caps and glaciers. Another 30% is groundwater, way, way down deep in the earth. So the stuff we actually use day to day, the water in our rivers and lakes, it's less than 1% of all the fresh water on the planet. Just think about that. Yeah, all that frozen water actually has a name. It's called the cryosphere. A good way to think about it is like the planet's long-term savings account. It's where most of our fresh water is stored, but it's in a deep freeze. And a real kicker, it's locked up in places like Antarctica and Greenland, not exactly convenient for most of us. I just can't get over this number. Less than 1%. Let that sink in. Every single city, every farm, everything humans have ever built has relied on this tiny, tiny sliver of the planet's water. It really makes you look at a simple glass of tap water a little differently, doesn't it? All right, so we've got it. The amount of water we can actually get our hands on is incredibly small. But here's the next piece of the puzzle. It turns out the size of where the water is stored isn't what matters most. It's the job it does. We have to stop thinking of water as just sitting in big pools and start thinking of it as a planet-wide delivery service. And this right here just lays it all out. Think of the ocean as a gigantic warehouse. It holds nearly everything, right? 97%. But the atmosphere, which holds a ridiculously small amount, just 0.001%, that's the delivery truck. It's the engine of the whole system, the global transport network that picks up water and moves it where it needs to go. So let's talk about these tiny titans. These are the real workhorses: the atmosphere, the rivers, and the biosphere, all the water in plants and soil. They hold almost no water compared to the ocean, but they do all the heavy lifting. If the atmosphere is the main superhighway, then rivers are like the local roads that bring the delivery right to our door. And the biosphere? That's the customer, actually using the delivery to keep ecosystems alive. Okay, so we know where the water is stored. Now let's talk about how it moves. This is where we get to see this beautiful, elegant system in motion, the global water loop. At its heart, it's a really simple but powerful process. It's basically 4 steps. First, the sun's heat pulls water up from the ocean. That's evaporation. Then, our tiny titan, the atmosphere, grabs that water vapor and carries it overland. Step 3, that water falls back down as rain or snow. And finally, the rivers act like a conveyor belt, carrying any extra water back to the ocean, and the whole thing starts over. And this isn't just some abstract science diagram. This is real. Seriously, a water molecule could evaporate from the middle of the Atlantic, get carried all the way to Europe, fall as rain over Germany, flow into the Rhine River, and make its way back to the sea. It's just one massive, interconnected global system. Now, what makes this whole loop work is actually a really clever imbalance. It's like this. The oceans evaporate more water than they get back in rain. And on the flip side, the land gets more rain than it loses to evaporation. That little bit extra, that surplus of water on land, is everything. It's what fills our lakes and rivers. And then the rivers just do their job. They carry that surplus back to the ocean, which perfectly closes the loop and keeps the whole system in balance. So it's great that the whole planet has this balanced system, right? But, and this is a big but, just because it's balanced globally doesn't mean it's balanced locally. Not at all.
In fact, that big global balance is built on a ton of local imbalances.
And you can see exactly how this works right here. Take the tropics, for example. Lots of sun, lots of heat, which means tons of evaporation and tons of rain. The result? A water surplus. But then you look at deserts. The atmospheric delivery service, well, it just doesn't make many stops there. So you get a permanent water deficit. It's the same global cycle, but the experience on the ground is night and day. And there we have it. That's the answer to the question we started with. The reason we have water scarcity on a planet that's covered in water is because nature's delivery system just isn't even. It's not a bug, it's a feature. It's just how physics works. But that one simple fact is what drives water insecurity for literally billions of people around the world. So that's the deal. That's Earth's natural water budget, a system that's been balancing itself for thousands and thousands of years. Which leaves us with one final, really important question. It's not just about how the system works on its own. It's about what we're doing to it. How are our actions, our cities, our farms, starting to tip this ancient, delicate scale?